Let's take a quick look at correlation and correlation coefficients. So for correlation, we have three ways to describe that. We can say that a correlation or a relationship or an association is positive. So like the association between the amount of hours you study for an exam and your exam score. If you are currently studying, I could probably predict that you're going to have a better exam score than if you didn't study. As the value of x increases, the value of y also increases. We can see that as x is increasing from left to right, our y values are also increasing from left to right. We can also see that if we went ahead and drew an approximation for a line of best fit, also known as a trend line, you can see that that line has a positive slope. The opposite is true for negative relationships, such as the relationship between the amount of snow cones sold and sweaters. As the value of x increases, this time the value of y decreases. And we can see that moving from left to right. That this time, moving from left to right, our y values trend downwards. If we go ahead and draw that line of best fit or trend line through those points, we can see that it has a negative slope. And our final way to describe association, relationships, correlation is no association, such as the association between a person's age and the amount of socks that they own. As you can see, our scatter plot dots are all over the place. They do not trend upwards or downwards. We cannot draw a line of best fit, so there's no association. The change in one variable has no effect on the other. And something we use to measure both the direction and strength of that relationship is called the correlation coefficient. The letter we use for that is R, and it is a value between -1 and 1 used to measure both the direction, so positive or negative, and strength, weak or strong, of a linear scatter plot. Here's a number line showing all the values of R. R can be negative, and we can have a negative correlation, or R can be positive, and we can have a positive correlation. R can also be strong, as we get close to either -1 or +1, or R can be weak, as we get further away from -1 or +1. Strong R values tend to fall between somewhere around 0.7 to 0.9, and that can be -0.7 to -0.9. Negative does not mean weak. Or it can be strong, somewhere between 0.7 and 0.9. It could be a strong negative, or it could be a strong positive correlation. It can also be weak. Our weak numbers tend to be somewhere between 0.2 to 0.5, 0.6, somewhere around there. Both positive or negative. And then lastly, we could have no association or no correlation. And these are our values that are very close to 0. Let's take a look at a quick example of calculating the correlation coefficient. This example right here, a children's museum reports the number of visitors in a month compared to the number of rainy days in that month. The relationship is modeled by a linear function. So to calculate that R value, we will open up our calculator, open up a data table by clicking stat1, typing in all of our data. For linear regression, you cannot just type in 2 points. You have to type in every single data point. After you do that and double check that all your data was typed in correctly, you can go ahead and hit stat, calc, go down to 4, linear regression, ax plus b, and click enter. And you should see this. You should see an a value, a b value, r squared, and r. If you do not, then you will have to take one extra step, and that will be clicking mode and double checking that stat diagnostics in your calculator is turned on. If it is turned off, like I just did in my calculator, when you do stat calc 4, you will only get an a and a b value. So you'll have to hit mode and double check that stat diagnostics is turned on. Lastly, you want to make sure that you take the r value for correlation coefficient, not r squared. We do not use that r2 or r squared in this course. And you will probably not see it written as 0.818. You will most likely see it rounded to the 100th place or 0.82. Since this value is very close to that positive 1, we could say that this is a strong, since it is close to 1, linear, and positive, since it is positive. There's a strong, positive, linear relationship between the number of rainy days and the number of visitors.